Question number 2 of exercise 7.10. Now the question is, evaluate the definite integral, that is integration of square root of phi cos phi to the power of phi d phi from the limits 0 to pi by 2. Now to solve this definite integral, we assume that the given definite integral is equal to I. And next thing what we are going to do is to make substitution so that this given function, that is square root of phi into cos phi to the power of phi, can be integrated. So for this, what I do here, I write this definite integral like this. All the terms as it is. What I've done, I've written cos phi to the power of 5 as the product of cos phi to the power of 4 into cos phi. Okay, and the rest terms are as it is. And further what I've done, I've considered that cos phi to the power of 4 is equal to cos square phi whole to the power of 2, and cos square phi can be written as 1 minus sin square phi and whole square as it is. So this cos phi to the power of 4 is written as 1 minus sin square phi whole square. Okay, now next what I can do is this, that I can substitute sin phi as equal to t. Okay, so when I substitute sin phi is equal to t and differentiate with respect to phi, I get cos phi d phi as equal to dt. Okay, so instead of all the sin phi, I can place t, and for cos phi d phi I am going to get dt. Okay, and when I make substitution, the limits are also going to change, and the change of limit will take place like this. Because sin phi is equal to t, so when phi is equal to pi by 2, then this means that t is equal to sin pi by 2 or 1. Therefore upper limit is equal to 1. When phi is equal to 0, then t is equal to sin of 0 or 0. Therefore lower limit is equal to 0. Okay, so on performing the substitution, I get I as equal to integration of square root of t into 1 minus t square whole square dt from the limits 0 to 1. Okay, now we can easily simplify these terms. They are going to become simple algebraic functions, and we can easily integrate them. Okay, now it would be done like this. First of all, I open this square, so this can be written as t to the power of 4 minus 2t square plus 1, and the square root of t can be multiplied to each of the term, and which gives me t to the power of 9 by 2 minus 2 into t to the power of 5 by 2 plus t to the power of 1 by 2. Now I can integrate each of these terms individually, and you can see that in this step I have only multiplied or simplified the product of square root of t with this bracket, and all the terms are as it is. Now I can integrate each of the term and write this t to the power of 9 by 2 as t to the power of 9 by 2 plus 1 upon 9 by 2 plus 1, which gives me t to the power of 11 by 2 upon 11 by 2. Similarly, this 2 as it is, t to the power of 5 by 2 is integrated as t to the power of 7 by 2 upon 7 by 2. Further, t to the power of 1 by 2 is integrated as t to the power of 3 by 2 whole upon 3 by 2. And further, in this step what I have done, that if I place the lower limit first of all, then I am going to get 0. This term also has 0, this term also has 0, because 0 to the power of any value is 0, and therefore all these three terms would be 0. And when I place 1, I am going to get 1 upon 11 upon 12, so this will be equal to 2 upon 11. Similarly, when I place 1 in this term, I am going to get 4 upon 7, and this will be equal to 2 by 3. Okay, so this is how I have solved for the upper limit and the lower limit to obtain this expression, and this can be simplified because LCM of 11, 7 and 3 would be equal to 231, because all the three are prime numbers. Multiplying them, I'm going to get 231, and this would be giving me 42 minus 132 plus 154, which is equal to 64 upon 231, which is the required answer. So in this manner I'm going to solve this question. Friends, thanks for watching my video. To watch more of these super videos and for the latest updates, subscribe and like the videos on these channels on YouTube, HSK Shiksha and Math Help by HSK. Thank you.